Hello everyone, today is the 10th day of Leetcode 75 challenge. Let's begin the 10th question. Question number 283, move zeros and level of the problem is easy. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in the simplest way possible. So you have been given an integer array nums containing both 0 and non-zero elements. Okay, it may contain 0 and non-zero elements and move all zeros to the end of the arrays while keeping the relative order of the non-zeros unchanged. So we have to return an output as an answer without changing the relative order of the non-zero elements. Like 1 comes before 12, so it will be 1 and 2 rather than 12 comma 1. Okay. So this is all what question is asking us. And constraints will be length of the nums could be from 1 to 10 to the power 4 and values can be from negative 2 to the power 31 to positive 2 to the power 31 minus 1. Okay. Now let's move to the next slide and understand the input output of the problem. So this is the input given, which is 0, 1, 0, 3, and 12. Right? Output is 1, 3, 12. How? Here we are getting 1, 3, 12 as the output by putting all the zeros at the end and keeping the relative order of 1, 3, and 12. Okay. We don't have to care about the relative order of the zeros because zeros are zeros. We don't have to worry about them. We just have to worry about how we're going to keep the uh, relative positions of the non-zero elements. So this is all about the input-output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition. Okay. Imagine you are organizing a row of shoes at a shoe store, and you are working at a shoe store, and you would ask to neatly arrange and display the shelf. And customer often leave shoe in a messy way in some empty spaces scattered between. The goal is to shift all the actual shoes forward while keeping the order intact, pushing the empty spaces to the back. So you just have to uh, order it as is, in a non-empty array. So this is the way shoes are arranged in the shoe rack right now. Fine. Okay. Here zeros means shoes and the empty blocks are basically the empty shelves. Okay. Now we know that this is the empty space here. Okay. And we will go ahead and check for a non-empty shelf. So as soon as we find a non-empty shelf, our first intuition should be replace this shelf value or the shoe with the earlier found empty shelf. Okay, this could be our first intuition. This, if we do this, what will be our output? We will remove this, and we have zero here. We have the zero here, which is shoe, and this becomes empty. Okay, and now our second goal is again we will come here and we will see. Okay, this is the another empty space after that and another non-empty space after the first empty non-empty space was this, right? We will swap then again, right? We have zero here now and we have empty shelf here. Okay, so we will take this in consideration as we have this empty space and we keep on going to the end. We will check. Okay, this is another empty non-empty shelf, so we will replace it to the one here and we'll keep on going. So this is how our intuition could be. We just have to find the first non-empty shelf and replace it with the empty shelf found earlier. If you can see here, we start with beginning and scan each shoe spot carefully. Whenever we find a proper shoe, which is a non-zero element, we swap it to the forward first value empty spot, which is a zero, right? So if you see an empty space, you keep moving and you keep on looking for the next shoe to bring forward. By the time you are done, all the shoes are properly displayed. So this is the intuition we're gonna follow, and I hope you understand how the intuition works. Now let's move to the next slide. Before going to the approach, let's understand what this two pointer concept is. Two pointer is a technique where we use two different variables, which will be pointers obviously, and to traverse an array, string, or linked list efficiently instead of using nested loops. Okay, how it works? You place two pointers at different position. The common one is starting position of the array and the ending position of the array. Okay. Move the pointers towards each other in a specific direction based on the conditions. So we have to move pointers to each other based on the conditions where they're going to be terminated. And this also helps in reducing the complexity from of n squared to n. So there could be some conditions in which, let me be more clear to you. There could be conditions where we are traversing in O of n scenario, right? For loop is there and another for loop is within it, right? But if we have to convert that n square approach to O of n, we could use two pointer in that case. If this is the array, right? We could place I here and we can start j from here or from here also or from here also. It is not mandatory that always j and I will start from start and end. The position could be anywhere. But the thing is that it should work in such a way that it reduces the complexity from O of n square to O of n. There could be one more case like this. You're starting from here and going this side and this side, right? So this is what this two pointer is all about. Basically, we try to convert O of n square to O of n, first thing. Second thing, if we have any question like where traversing in a single point is manageable, we use two pointer there. And places where we use two pointers could be sorting and searching when dealing with sorted arrays to optimize search operations. Linked list for detecting cycles. Here we use the concept of fast and slow pointers, which we will study when we solve the questions based on linked list, and finding the middle or reversing efficiently. In string manipulation, when modifying or comparing or checking conditions on a string, in sliding window is the most important one to use two pointers for finding sub-arrays or substrings for specific properties. Two arrays processing, which we are doing right now, when merging, comparing, or finding intersections of arrays, and gradient optimization when solving problems that require scanning from both ends. As I said, we can go from here, from start and beginning. Okay. I hope you understand why we are using two pointer concept and how it is done. Let me give you one more small example. Like if we have this sorted array and we have to find some, say, 5, right? Not 5, let it be 4 and let it be 5. Okay. Now we are asked to find a value as 2 plus 5, 7, right? Okay, we have to find 7. Optimized way using two pointer would be we will start from start and one from beginning. We add these two values, we get 6. So from here we could understand that 6 is less than 7. So what we will try to do, try to move the left pointer towards right. 2 plus 5 we get 7, so we got our output. And this could be same done in the O of n square opportunity complexity by traversing start keeping index 1 and traversing this complete array, then keeping this as 1 and traversing this complete part. So yeah, so this is one of the examples I could take right now for understanding of the two-point concept. I hope you understood it now very clearly. Now let's move to the next slide. Now, since you got the intuition of the problem, let's look into the approach how we're going to solve it. So as I right now explained you about the two-pointer concept. So we will be using two-pointer here itself. That is why we have understood how two-pointer works. For two pointers to use the concept of two pointers, we need two pointers first of all, which could be I and J in this case. Okay. And we will initialize it to 0. Okay. Now we have to keep in mind that we have to keep the relative order of the arrays intact. So if you take this example 1, 0, then some values like 3, then 4, let it be, okay, and let it be 0 at the end. Now, in intuition, we try to understand that we will try to fill up the first or earlier empty space which we found with the current non-empty space, right? What if you think of doing it like this, putting I here, putting J here, and I here, okay? We will take j as the main terminating condition when j reaches the end. Fine. I will be following j. I will be following the j. So we are running j. Okay. This would be one thing to be done, right? This keeps track of the position where the next non-zero number should be placed. So I will be trying to find out which index to be filled with the non-empty space. Okay. And j will try to find out the non-zero numbers. Okay. Basically, I will keep the track of where the non-empty space is, and j will try to find out non-empty spaces. Okay. Basically, it will track the zeros, it will track the non-zeros element. Fine. Okay. But we will both start with 1 1. Okay. We have this clear in our mind that we need to do things, and this could be our way to go. Now, what to do? Now we'll iterate through the array. Okay. While j is less than n, we have to check every element. So j will be the main element, so it will be less than n. Fine, but that is understandable. Now, if nums of j is non-zero number, if it is a non-zero number, then we will swap it. But right now we cannot do it, right? Right now we have to find if it is a zero element, right? If nums of j is zero, we do nothing because I is keeping track of the non-zero elements right here. So what we will try to do? We will try to move j here. Okay, we found a non-empty element. Okay, we have to keep the relative order also. Keep that in mind. So the best thing which comes to our mind is that we swap these values. One comes here and zero comes here. Okay, okay, this could be done. And we had j here. Now since the swap is done, when swap is done, we move forward I plus one, the correct place. I will be here. Okay, and j will also be moved here. But j will skip this value zero because it's aim to find the non-zero elements. So it will come here. It got another non-zero element. Right? What you gonna do? It will swap this again. So it becomes 1, 3, 0, and 0, then 4, then 0. And I from here comes here again in the zeros position, and j comes here. Again it will get swapped. We get 1, 3, 4, 0, comma 0, comma 0. And j comes here, it's still 0. It will try to move ahead, and the loop array will size of the array will end, and the loop, and we will come out of the loop. Right? Move j forward to every step to continue checking all elements. Handling a zero. Since I only moves when a zero number is found, all zeros automatically get pushed to the right as we swap elements. Here, if you saw this example, 0, comma 1, comma 0, 3, comma 4, comma 0, you will see we are starting the I from this position and j from this position. Okay, and if this could have been a non-zero element, for example, let it be 1, let it be 2, right? J is here, I is here, right? J is in a empty non-zero element. We will try to swap this according to our condition. Okay, it becomes 2 itself again, right? But what happens is that J comes here along with I, right? Again, they will swap each other. I will come here and J will come here. Now, J will skip this value because we have got first value where I is 0, I's value is 0, and J is also 0, but J will skip and go for the next value 3. Now we got another non-zero element. They will swap this element and it will become 3, comma 0, and I will be extended to 0 next index, and J will come to the next index which value is 4. Again it will get swapped, and this is how it will go. So we have to keep in mind that I will be tracking only the zero elements, and J will be tracking only the non-zero elements. And whenever we get a non-zero element, we try to swap it with I, no matter what value of I is present there right now. it will automatically come to an element containing 0 in it. Okay, as just we saw in this example, even if I is in non-zero elements, we will try to swap these values and we will move ahead I and j both here and here. Again, if they find another value non-zero and they will swap it again, and again I will come here and j will come here, and eventually I will be in a place where I is equals to 0 and j will figure out its stuff along with it. So this is what the question is the approach is here explaining it. I hope you understood the approach, how we are using two pointer concept here to finalize our answer. Okay, now let's move to the next slide. The code is exact copy of the approach discussed. Let's understand it line by line. We will start I and j with 0. We will take the length of the lumps array. Okay. Now since j is looking for non-zero elements, so this will be our deciding factor for the complete array to be iterated because j will keep on running till it does not find any non-zero element. Okay. If j is not equals to 0, which means j found a value which is non-zero element, we will swap it as discussed and we will increment j and I both. If j is in some value which is equals to 0, it will just skip it and move ahead. Look, here we are not skipping I because if I is in 0, we need I so that we can swap j with I, right? And the complexity of this problem comes out to be O of n as we are iterating only array of n n times. And space complexity is O of 1 because we are not using any extra data structures to store the answer. I hope you understood the code logic and how it is working. Now let's move to the next slide. Now since we have the understanding of the code, let's look at a dry run of the example. I have taken this example 0, 1, 0, 3 and 12. Fine. According to our question, I and j starts from 0th index, right? This is j, this is I. Okay. But our condition says that if j nums of j, let n be the nums of j, if it is not equals to 0, okay, swap, okay, I plus plus and j plus plus, right? Else only j plus plus. Fine. In this case, we can show that j is equals to 0, so j will be incremented and j will come here. Okay. Now our first condition becomes true. Here nums of j is not equals to 0. We will swap these values, right? So after swapping, it will become 1 comma 0, 0, 3 and 12. Okay. And now I is here and j is here. Fine. Now again is j equals to 0. So it will skip this value and move ahead to 3. Now j is here. Now again our first condition becomes true. If j is not equals to 0, it will be 1, it will be. Now we will swap these values. So we will get 1 comma 3 comma 0 comma 0 comma 12. Okay. Now I was here in the second index. Now I will come this side in third index and j will move to the next index which is last and the value is 12. So again our first condition becomes true. So we swap the values again. Okay. And j moves out of the loop and I comes here and we return this array and we get the expected output 131200, which is our output asked. I hope you understood the dry run. If you have any confusion, I would like you to go through the approach again and the intuition and the concept of two pointers if you are not aware about it, and do the dry run again with the new example. and see if you understand the problem in a more easier manner. Now let's move to the next slide. Now since you're familiar with the problem and solution, let's move to the lead code and code out the solution. We will keep I equals to 0 and j also equals to 0. N equals to length of nums while j is less than n. This j is the deciding factor of the ending of the loop. If nums of j is not equals to 0, the nums of j comma nums of I will swap both index values, okay, and increment j plus 1 and I plus 1. Else we'll just increment I j. And since the question does not ask to return anything, and we have to modify the array given itself, so we'll submit the answer now. All cases got passed. Now let's submit the solution. We have successfully submitted our approach to the problem. The code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.